So thank you so much for joining the session of Visual Studio Debugging powered by Copilot. It's the last session of the day, so thank you for still being with us. For the quick introduction, my name is Harshada. I'm a product manager in Visual Studio's debugging and profiling team, and I have an amazing co-presenter with me today.
Hi folks, I'm Charlie. I'm the engineering manager for the Visual Studio Debugger team.
Thank you, Charlie. So yes, you have heard Copilot word at least a million times now, maybe. We will be talking about Copilot too, but in the debugger context. So we'll be sharing you how we have been improving existing debugging features with some Copilot integrations and how you can actually use those features to make your debugging experience much more better. Before I start, I have a question. How many of you here really love Visual Studio Debugger? Wow, that's great. Thank you so much. We hear that feedback all the time that we love Visual Studio Debugger, and we really appreciate that love. So it was really great to see that. So as I said, we will be talking about Copilot features in the context of Debugger. We'll see some basic features from breakpoint as well as some complex scenarios. All of our demos are live. So Debugger and Copilot demos, it's possible that it may or may not work. So just ignore that if it happens. Okay, with that, I'm going to hand it over to Charlie to kick us off with our first demo.
Okay, so we're going to have a lot of short demos for you today, and each of them will cover a different aspect or capability of Copilot in the debugging scenarios. And hopefully by the end of the talk, you will have a good feel for how they can all be put together and they can help you with your debugging productivity in Visual Studio. Now, to kick things off, I would like to start with the core features such as the context elements in Copilot, because they are really key to using Copilot effectively in the debugging scenarios. And we're going to start with taking a look at a quick or a simple troubleshooting flow. I have a simple test application here that allows customers to buy .NET related merchandise. And let's just say the issue we're going to take a look at happens in the shopping cart page. This is the page where I can just use this quantity text box and change the quantity of items I want in my shopping cart. And the particular issue that we're going to be investigating is the one where, when I update the quantity to 0, I expect this item to be removed from this shopping cart. Let's try that. And what happens is, okay, the cost is 0, but this item still exists in the cart. And the worst, because it exists here, it allows me to go through this checkout process. Let's log in. And then I can even place an order, which is a completely invalid state. So that's the task. And let's go back to Visual Studio and then try to figure out where things are going wrong. Now, if you noticed, I have a fairly complicated application here. It has a ton of files here and classes. So the task at hand is to isolate the code where we think the problem, which has the problem. Now, I'm going to go ahead and use Copilot for that purpose. And more specifically, I would like to introduce the first context element we're going to cover today, which is the solution context element. A context element, if you're not familiar with it, allows you to attach additional piece of data when you write a question to Copilot. And it's really important to use specifically for this purpose. The solution context element is the one you want to use if you want to refer to your solution as a whole. And what I'm going to do here is ask Copilot about where this problematic code might be. So let's just say, where is the code that updates the quantity of items in the shopping cart? All right. Now, while it's doing its thing, let's take a moment and think about how we would do this normally. Again, this is a fairly large project, and if you're not familiar with it, you would have to probably browse through the sources and try to get a feel for the project structure. Or you might try doing some text search just to see if you can stumble on some class that might be relevant to the issue at hand. But what you're doing with Copilot here is just doing a semantic search against the code base. The solution context element has the full index of the open project, and Copilot can understand your intent and can go through the search process effectively. Let's take a look at what answer it came up with. All right, so it's actually more than what I asked for, which is great. So as you might expect, there are multiple components involved during this update flow. So it's starting its answer by going over the UI layer, where it's basically telling me everything starts in this index.cshtml file. And then there's a on post update method that handles the submission of the form. And scrolling down, we come to the business logic layer. And more specifically, there's a class called basket service, and it has a set quantities method that simply processes the updates. Right. So this is actually where I want to be. So it's very good that with just one prompt and adding the context element, I was able to get to where I want to very quickly. At this point, I can simply ask Copilot about this particular method. Let's see. I can say explain the. Again, I can invoke the completion list by just typing in the hash key, and then I can select the method here and simply ask Copilot to tell me what's going on here. Now, this is obviously a simple function, so maybe this you might not need it in this case, but think about all those functions that can be quite large and having a complicated logic. So this is a really good way to get up to speed on the code and understand what's going on. We're not going to go through everything, just we're going to browse through what it's saying. Basically, it starts with basket retrieval. It then goes through quantity updates in a loop. And there's also a discount application at the end of it. And so this is great. Okay, I think at this point we can talk to Copilot about the problem we have and let it think about how we might go about fix it. Let's say, I'm going to say something like, when I update the quantity of an item to 0, it still remains in the shopping cart. Can you fix it? All right, so it's working. And it came up with an answer. It says it can see the issue. Great. When a quantity is set to 0, the item is updated, but not removed from the basket. And it's also saying, I noticed the basket class has a remove empty items method that should handle this. So that's great. It's looking like it's going to be a simple fix. And it goes ahead and reads the definition of the basket class just to understand how it works and come up with the fix. And we're going to scroll down to the updated method that it thinks should handle this case. At this point, I'm just going to hit the apply button and simply look at a diff view of this change. It's a simple one-line change. I'm going to go ahead, hit the tab key to accept it. We are still running in the debugger and we have hot reload available. We don't need to stop, rebuild, and try the scenario again. I can just apply the code changes, come back and reproduce the same scenario again. Now we have 1, and let's get it down to 0. And hopefully when I click the update button, we see the basket or the shopping cart getting empty. There you go. Okay, so that worked. That was a very quick way for us to isolate the code and find the code using Copilot and get a fix out. All right, so that was the first context element I wanted to cover. And the next one is more specific to debugging scenario. And for that, I am going to set a breakpoint in the apply discounts method. Sorry, actually, let's go through the example first and then, okay. So here's the second bug we're going to go over. as you can notice, there's a 10% discount if I get 5 or more of this item. And I go to the shopping cart. Again, I update the quantity to let's say 5. And at this point, I want the discount to be reflected, but it's obviously not happening here. And we're going to debug this code and to understand what might be going on. Everything is in this apply discount method. So I'm going to go ahead and put a breakpoint and try to understand what might have happened. Exercise the scenario one more time. Okay, so we're here. I look at the unit price. It should have been updated now. I would have expected it to be like 9 because of the 10% discount, but it's still 10. And at this point, what I'm going to do, let's start a new thread. I'm going to use the debugger context element. This is one of the built-in ones, and it's available to you whenever you're stopped in the debugger. And what it does, it captures the whole debug state of the target application you have so that you can ask Copilot any question about it. This includes, the current location we're at, the call stacks, the locals, and the general application state. And what I'm going to ask Copilot is, the discount didn't apply to the current item. Can you understand why? If you were to do this without debugging, and if just pointing at the code, Copilot would come up with maybe a few different things that might be happening, but it really does need this extra context and details to really understand what's going on and give you the correct answer. So maybe some of you might have noticed, but what's going on here is we're keeping the discounted products in a hard-coded list. There's actually a typo in one of the items we have. So even though this Rosen red sheet should have a discount applied, because we have a slight typo in here, we're not going through the kind of the discount logic. All right, so as you can see, it's explaining to us it didn't apply because there's a missing character. The actual counterclaim is different. And when we call the try get value in this from this dictionary, it fails to find a match. So that's how it works. Now, this was just a simple example, but in a different application, let's say you have a very complicated call stack and whatnot, you can use this debugger context element to ask a detailed question to Copilot. All right, so that was our second example, and I want to move on to my third example here. All right, so you might have seen the vision support in Copilot. And usually when we demo that, it's about kind of how, showing a picture of how you want a future to look like. And I wanted to go through an example where it might help you with kind of figuring out what's wrong with your application. And here, what I'm going to do is, as you can see, when I make this window slightly narrow, there's a slight UX glitch here. And rather than trying to explain Copilot, what's going on, sometimes it's just simpler to take a screenshot here and then go into the Copilot window. And I can just do Control V. This will just paste the image or paste a screenshot as an image attachment to my prompt. And I can say, can you fix the UX glitch with the total column in the order history page. Now, I've done this example before. What happens sometimes, Copilot sometimes tries to do a very extensive fix, and I don't want that to happen. So I'm just going to say just a minimal fix in the front end is fine. And let's see what Copilot comes up with. Okay, So basically it's telling me the total column has a formatting problem with a very large number and misaligned data. And it's going to go ahead and try to find the kind of relevant code snippets in the solution so that it can figure out where the fix should go. All right, it's still searching for items here. It's trying to find the orders view. Okay, so it's telling me it found the issue. The total column is not properly formatted for currency display. Okay, let's go through and take a look at the fix that it came up with. I'm just going to go ahead and hit the apply button. It will immediately take me to my orders page. Okay, I'm just going to go ahead and accept the change, save the file. And again, I can use hot load to have the changes reflected immediately. And hopefully when we go back, all right, there you go. So that UX glitch is gone. And it's actually, it added a kind of commas for me to see in a nicely formatted way the total for an order. Okay, so with that, these covered all of some basic features that I wanted to highlight. And I'm going to hand it over to Harshada now.
Thank you, Charlie. Okay, we have a lot more demos to go, by the way.
Yeah, we're going to switch back and forth. So if you don't mind the applause.
So we saw how you can just use Copilot without even getting into debugging yet, like to understand your code or to understand your application. Now let's just get into some basic features of debugging, like breakpoints or visualizers. So I have a very simple application which I created just for the demo. It's like a car application that collects all the information and gives me the list of cars at the end. If you see here, I have trying to generate 300. Oops. Okay. I'm trying to generate 300 cars. So I'm expecting that when I run my application, I'll see all the 300 cars with its detail. I just want to validate that. To do that, what I'm going to do is I'm going to use something called force run to cursor. So I have a lot of code here, a couple of breakpoints. I want to skip everything and just see and run my application to see the output. So what force run to cursor will do is it will skip all those breakpoints, like stopping at those breakpoints, and it will also skip any first chance exception if that happens. So just right click on the line you want and then do force run to cursor. This will run the application and give me an output, an easy way to fast forward your debugging or just validate something. So working. I forgot to do one thing. Let me start again. Okay, let's start again. So let's try doing the force run to cursor again. Something went unexpected, as expected. Okay, perfect. So you'll see I'm only seeing 265 cars. That's definitely not 300. So let's try to investigate what is happening here. To do that, what I'm going to be doing, I'm going to be placing a breakpoint. That's the one thing we always start when you start debugging. I'm going to have a breakpoint on this generate cars function on this line for event. Just going to enable that. What I want to do is I want to validate the data which is coming in this list to see if there is an inconsistency. So I'm going to go and start my application again. It will stop the execution at this breakpoint. Now, if you wanted to validate your data, you have this tooltip here, which you can use. You can see you can hover over each an item and check the data as well. But there are 300 items. So what we'll do is we'll use something called INumerable visualizer. So this is a great way to validate your data or visualize your data in a table format. You can sort your data. You can even export your data if you want to. Now, if you notice here, I'm seeing this weird looking price. It's negative in a very large number. I'm just curious to see how many of those prices I have in my data right now. So what I can do is I can go and write a link expression in this expression box manually, or I can just click on this sparkle button and ask Copilot to do it for me. So I'm going to do give me all cars. I can't type, that's fine. Okay. And what it will do is it will not just create the link expression, but it will also filter out. Again, it's a very simple example, but you should be able to use that for complex scenarios as well. So it's telling me that I have around 45 cars which are negative, and it's possible that those cars are getting filtered out, and that's why I'm not seeing it in the output window. So let's try to figure that out again. Before I do that, I want to show you something in my breakpoints window. Again, I have only a couple of breakpoints here, but if you notice, I have those breakpoints in nice breakpoint groups. So when you have like a large list of breakpoints, I think breakpoints group can really help. And if you are doing like on investigating multiple issues, this will be really helpful. For me, my different demos are my different scenarios. What is happening?
I'm unplugging, plugging it.
Okay. Nope. Okay, came back. So previously I was showing the visualizer demo. So I had the visualizer breakpoint. Now I'm going to go to my breakpoints demo. So I'm just going to enable the breakpoint. So it's easy way to disable, enable the set of breakpoints, and you can investigate multiple things at the same time without removing your breakpoints. Now, I have this function here called adjust car price, where I'm just calculating some discounted prices and then assigning that price to the car price. My assumption is that something is going wrong when that particular discount price is calculated, and that's why we are seeing the negative value. So to start with my investigation, I have a breakpoint on line 41 when the car price is assigned. I don't want to hit this breakpoint 300 times because we know we have this for loop here for 300 cars. So what I'm going to do here is convert this breakpoint to a conditional breakpoint. So if you don't know, conditional breakpoints are super handy if you wanted to have your breakpoints hit on a particular condition or a particular scenario. Again, you can write any conditions you want in this text box, or you can use Copilot's help again. You just place your cursor in the text box, and Copilot will actually come up with 3 possible suggestions. Now here, I'm not exactly getting the suggestion I want, but I still feel that having these suggestions is really helpful for some complex scenarios. You can at least get some ideas about the conditions or just remember the syntax too. So I'm going to update the condition I want. I want this breakpoint to hit only when the price is negative. It's going to close here. So this breakpoint suggestions also works great with trace points. Trace points are very similar to log points, which help you log certain important information and show in the output window. But the good part is you don't have to remove them when you wanted to push your code to the production. So let's convert this breakpoint on line 81 to a trace point. Again, go to settings and do actions. And similar to the conditional breakpoint, just place your breakpoint cursor here, and Copilot will suggest some good log messages. I'm going to go with the second one here because I want to understand which particular discount is giving me a negative value. So I have a very small tip here. Like sometimes when you work on these conditional breakpoints or any advanced breakpoints, and if you just delete it like this by mistake, the Control Z or undo works completely fine on this. So your conditions, your actions come back with that undo button as well. I'm going to go ahead and start my debugging again. So what I'm expecting that I will only hit this breakpoint when the price is negative, and this particular log point will tell me what particular discount is negative so that my price is getting negative. So let's start again. Okay, and I'm going to go to my output window here. And if you notice here, it is telling me the prices from all the discounts. It's telling me that the very old car discount price is getting negative, and that's why something is happening when I'm calculating. I'm not going to go into the details of this, but I have a function here somewhere where I'm applying all the discounts.
Further down.
Sorry?
Further down.
Yep. So I think for everything else, I have a percentage, and for this one, I have a fixed value. And That's why the calculation is messing up. So again, these were super simple ways where you can just use existing debugging features like visualizers, breakpoint, but with just help of Copilot, that makes it more easy to use or makes it more faster to use. We have one last demo to show, and that is around link debugging. I know I can use and here. I just put where so I can show this clause by clause debugging here. So when we have link debugging in general, it's difficult to see the data at each and every clause. So what we did here recently added a link hover. So again, I'm going to stop here. So whenever you hover over any clause in your link expression, you have this option very similar to what we saw in the list, where you'll have this option to visualize your data, like each item by item, or you can just use the enumerable visualizer again. Now, if you hover over the last class, you again have the same option, but you also have this Analyze with Copilot option, which will actually explain you what that particular link query is. And you can actually chat with that in that chat to update or fix your link query as well. Another way to fix your link query is, again, what we saw before. You can go to your enumerable visualizer. Just gonna do here. So what I'm trying to do in this particular function, get all the cars which are white, Audi or BMW, and has price greater than 45K. But if you notice here, when I hover, I don't have any item, or I don't see any item here as well. So I'm just going to take the help of Copilot to fix my query. Okay, so looks like something. Okay, so I had the W as lowercase, capital here, and that's why I think the query wasn't picking up, or it wasn't giving me the right result. But again, I just wanted to show you there are multiple ways when you hover over link query or when you step through the link query that you can fix your link query either through a visualizer or even through the Analyze with Copilot. So in the next demo, Charlie will show how you can actually use that Analyze with Copilot in detail. So that's all I had with the basic debugging. Now I'm going to hand it over to Charlie again for some of the advanced debugging scenarios. Yes, you can clap.
All right. So we covered the core features. We covered some productivity features that are inside your regular debugger features in Visual Studio. And we will move on now to more specialized flows. And the first one we're going to take a look at is exception assistance. Now, obviously, exceptions are pretty common, and they're usually the first sign that something's wrong, with our applications. And in Visual Studio, we provide a tailored experience for such cases. So I'm going to go ahead and run the application, which will throw in exception here. There you go. Now, before we enlist Copilot's help, I just want to briefly explain to you what's going on with this code. And this is a very simple code snippet. We have an HTTP client object. We're making a call to a remote endpoint. And then once we get the data, we're using a deserializer object and to kind of populate our list of products here. Now, there's obviously something going wrong because our list is empty. And this is the immediate reason why our application is throwing this invalid operation exception. Now, obviously, the more interesting question to ask here is why we even got to this place. And for that, we have a special experience, and which starts with clicking the Analyze with Copilot button in the exception window in Visual Studio. And when I click this button, what will happen behind the scenes, we're going to send to Copilot all the debug context, the details of the error message, and we will also give it some tools it can use if it wants to grab some additional data from the target application. And with that, hopefully Copilot can come up with a decent answer. So let's take a look at what it is doing right now. So the first thing it wanted to do was to evaluate this expression here. This is basically, let's see, the content of the response we got, and it wants to read it as a string. Now, this particular expression, since it requires us to run code in the target application, it might cause the application state to change, and we always require confirmation, from the user when we attempt such an operation. If it was just a regular expression, Copilot would have, grabbed the value behind the scenes without user intervention. Let's go ahead and say allow. And what I'm hoping Copilot will get this data and then use it in its analysis to come up with the right analysis. Let's see. It's basically saying the root cause of the deserialization error is a mismatch between the JSON structure and how we're trying to deserialize it. So the API is returning a JSON object with a products array, but we're trying to deserialize directly into a list of product objects. So it's giving me explanation about the data it was able to grab from the remote side. And basically, let's take a look at the fix. We need to simply create a wrapper class that matches the data we get from the server. And I'm going to go ahead, apply it here. All right, so it's a product wrapper object. So it didn't give me this is not by itself sufficient. I need to put that in here. So instead of using this object as my deserializing type, I need to use the wrapper object. Let me fix it up quickly. Deserialize that products. There you go. Okay, let's repeat our scenario here to see if we indeed fix the issue. Okay, so we didn't hit the exception, and when I hover over this product's property, I can see that now we have a list of 30 products in there. Okay, now before we move on to the next demo, I have a couple notes I want to talk about here. You might be wondering if Copilot could have fixed it without debugging, and it might have stumbled on the right fix, but the problem here is not with the logic in the code. And this is not production level quality code, but there's no logic error. It's just a mismatch between what the server is sending and what we were expecting on the client side. So we needed this runtime context for the Copilot to figure out how we might fix it properly. And the second note is this functionality has been in the product for the last, I think, more than a couple years now. The user experience is more or less the same, but what's happening behind the scenes is changing a lot. So if you're using it already, great. Or if it has been some time since you last looked at it, you might want to try again because its analysis capabilities are growing drastically over time. And we have quite a few things in the works to make it even better. All right, so that was exception analysis. Let's move on to our next demo. Now we're going to take a look at variable analysis that Harshada briefly touched on. I'm going to set my startup project here. And this time, this demo app is in C++. Let's start debugging here. All right, the interesting part about this example is this line here. We're basically using the Win32 API to create the process. We're trying to launch Notepad.exe on the system, and we're using this API from Windows 32. Now, when I'm going to step over this call, and create process will return false if the call fails, and you're supposed to retrieve the last error code from the system using this functionality here. Now, before we get to Copilot analysis, I want to quickly highlight the feature we've recently added. I think it's been in the product for the last 6 months or 8 months. Now, before the version, I believe 17.12, if you wanted to grab the return value of this function, you had a couple options. None of them were great. You would have to either copy this expression and put it in the watch window and see what it is. What most people did, they would just create a temporary variable, assign the value, and so that they can easily see that value inside the debugger. Or you would have to exit this function, obviously, and then look at the return value in the calling method. But now, as of version 17.12, as I'm about to return from this method, we're immediately showing you what this function is about to return directly inside the editor. And in this case, we're returning an error code to the calling method here. And this data type says this start process with defaults will return because the return actually hasn't happened, but we have enough information to understand, okay, this is the value that's going to be returned to the caller. All right, so I think this error code is kind of self-explanatory. There's one or more arguments are invalid in this call we made to the create process method in Windows 32. Now we got to understand why that might be going on. Now, if you were doing this without Copilot help, let's think about how we would solve this. We would have to open the documentation for this API. And as you can see, it takes a bunch of arguments. And we would probably go through the list in that API documentation, read the expected format, and then try to see what we're passing and kind of spot the difference between what's required and what we're doing here. Now, Copilot can automate all of that for you. We can simply invoke analyze with Copilot experience on this variable. And just like the exception assistant, what we're sending to Copilot behind the scenes is the current full debug context so that it can put things together and give you a nice explanation. All right, so let's take a look at its explanation. It first goes and explains to us what this code indicates, the error code, which is kind of obvious here. But let's take a look at its analysis. All right, so it's saying the environment block format appears to be incorrect. Okay, and I'm just going to highlight the interesting part here. And it says the Windows API requires the environment block to be terminated with 2 null characters and not just one. So because of that, it thinks the create process call is failing. And let's take a look at the fix here. I'm just going to go ahead and hit apply. And it should be rather simple. Yeah, it's just about adding extra null terminator strings. And I'm going to hit apply. I'm just going to not exit debugging. I'm just going to use hot reload to apply the change because why not? And then repeat the same scenario again. We're right at the point where we're about to call create process. And as I step over to call, I can see now everything is working properly and the create process was successfully called. All right, so this was variable analysis. Couple notes on this. You can invoke it and everywhere you can do variable inspection in Visual Studio. This could be the data types like here, or you can go to your locals window and then basically any property you have, you will see this Copilot icon next to it and you will get through this experience. You want to probably call it on items that you think have unexpected values. But I suppose if you just want to confirm something just looks right, you can also do that. For instance, let's just say, let's see what happens if we invoke this on the process name variable. I suspect Copilot will just say, thumbs up, everything is good. Let's see. All right, so it's basically telling us the value is correct and expected. So you can use it to confirm everything is right for a particular variable. All right, so this was variable analysis. Now moving on to my next example. It's going to be about using the output log analysis. I'm just going to quickly set up my repro app here and let it run once. Sorry, I forgot to remove some breakpoints. Let's disable them for now. Okay. I'm running the application one more time just to reproduce it here. Okay, I'm going to very briefly explain the code, but the details don't matter that much. So we have a shared resource object here. It's basically using a reference counting scheme. So any client that uses it, they're supposed to do an adref call, and once they're done, they need to release it so that we can understand when it's time to destroy this object and there are no clients using it. Now, in this demo app, I had a bunch of clients using it, and I'm about to exit the application. Let's take a look at what's going on. But I can see there's the ref count. At this point, I expect it to go down to 0, but it's at 5. So there's clearly some resource leaking situation. I will invoke Copilot here. I purposefully made this so that these clients are actually external libraries, so Copilot cannot really see what's going on inside them. So I think it's going to just tell us, hey, there's a resource leak issue. You got to really look at the client code here and understand how they are not releasing the resource. And okay, basically, this is the gist of it. We need to see the implementation of the client thread functions. So what I'm going to do here, I'm going to enable these trace points that I said before. Basically, anytime somebody calls at reference, I'm logging that statement along with the call stack. And I'm doing the same thing for releasing. And this way, I will have a full trace of adrefs and release across different clients in this app. Let's run the example again. And this time, I will have a lot of logging statements that I can see showing up in my output window. And if you were to analyze this yourself, you would have to really look at the mismatches between adrefs and releases. But here I can just use Copilot's help, and I can say, I've traced the adref release calls. Can you find a mismatch? And what I'm going to do, I'm going to add the output log from the debug pane as additional context element. And let's see if Copilot can spot the difference and find the client object or the client component which is not releasing this shared resource. All right. As you can see, it's basically telling us client thread G called adref but never called release. So it was able to quickly find the mismatch between different client components. Now, at this point, you would have to find the code for this external component and really understand what's going on. All right. So this was how you can use the output logs to kind of aid in your debugging. I used trace points to log something to the output window, but I'm sure your apps have their own logging logic or tracing logic, so this would work. Anything that gets logged to the output window in the debug pane, you can just use it like this. All right, now I'm going to, you have time, right?
Yeah.
My final example of the day, now we're going to take a look at a multi-threaded app. Okay, so this is stock market simulation app between 3, I guess, cats. All right, so, and when I start, the stock market simulation kicks off. And at some point, we're gonna see a deadlock situation. Here, we will, and let's see, the transactions will stop happening. And I believe we're already there. Okay, so I'm gonna stop the application to see, I want to check my current state of the app. And one thing I immediately noticed is Visual Studio telling me there's a deadlock between 2 or more threads. Now, this is not a Copilot feature. This is something built into Visual Studio for quite some time. So it was able to see some threads that are waiting on each other. At this point, I can simply go to the parallel stacks window. This is the window you want to go when you're dealing with a multi-threading issue. And you can immediately see there's a bunch of threads that we were able to flag as being in a deadlock situation. Now, what Copilot brings on top of this experience is, there are a couple of things here. I'm going to turn on show external code just to make this view a little bit more scary and more busy. I don't know. Let's see. Can we zoom in here? Yeah. All right. So one thing Copilot does is, looking at the call stack, just giving you a very short summary of what that call stack node is doing. This is basically telling us this particular node, this particular set of frames, it's not doing anything interesting. It's simply running the main application loop. And let's take a look at the other threads here. This one, there's 11 of them. They're deadlock situation. Let's see if there's anything other than interest. Yeah, so we know that the cat Felix thread, it's in a deadlock situation while it was attempting to execute a buy operation. So if you've used this window and if you have complex applications, you might have noticed it might get busy pretty quickly. So this quick summary that is provided by Copilot is really a nice productivity feature that allows you to get to the threads that are interesting. Now, the second thing I was going to show is just like the exception analysis experience, we have the Analyze with Copilot button that shows up when you have a deadlock situation. And just like that, just like the exception assistant experience, when you click the link, we're going to send to Copilot all the threads that we know to be in a deadlock situation so that it can come up with an analysis as to what might be going on. And just take a quick look at, let's take a quick look at the description it has. It's basically telling us that there are two threads that are each waiting for a lock held by the other, obviously. All right. This is the real problem here. The locking order is inconsistent in this code base, and that's why we're getting into a deadlock situation. And the fix is always acquiring locks in a consistent global order. Now, at this point, the Copilot didn't give me a fix, but I can continue chatting with it and I can ask it to come up with a fix. But in the interest of time, we're just going to stop it here and I'm going to hand it to Harshada. Thank you.
We saw many different ways how you can use Copilot with debugging, and in next session, we also saw how you can use it in profiling to improve those experience. Now, I have a couple examples how you can use debug, profile, and Copilot together in unit testing to help your unit testing experience. Again, I have a very simple application which actually manages the inventory for a grocery store, and I have only 2 unit tests here. So if you notice here, one of my unit tests is failing. And this is failing too. Okay. So if you notice, one of my unit tests is failing. Now, to investigate a unit test, there are a couple options you can do that. You can actually just debug it through it manually. Or what you can do is you can go to this Ask Copilot option.
Yeah,
okay. And there are again 2 ways you can do that. You can debug with Copilot. What it does I'm not going to demo this, but I'm just going to explain that. What it does is that it will actually create or start a new debugging session particularly for this test. It will place breakpoints on its own and then actually debug through it with you. This is a very simple failure, so like very small and simple failure. So what I'm going to do is explain failure with Copilot. Again, very similar to what we saw before in analysis, in exception analysis or variable analysis. What it will give me the exact reason why my particular test is failing. Now, looks like in this one, the cabinet is trying to have 2 items, each cabinet, but only first cabinet is getting 2 items, and that's why the test is failing. Now, what I can go is I can just ask for a very quick fix, like fix this for me, and it should able to give me a correct fix. Again, this is a very simple example, but as I mentioned, this should work completely fine with the complex scenarios as well. Now, I'm guessing I'm just going to blindly accept the change here, but you should go and review your code before applying. Okay. Okay, and now let's go to the test explorer and try to rerun. It's rerunning on its own. Okay. And I have build errors. Okay, Um, in the interest of time, I'm not going to solve those bill errors now, but it can happen when you work with Copilot. So the idea is that you should be able to use your failed test to investigate your failed test with multiple ways. Another thing I wanted to show you is, I think you saw it in detail in Nick's session, that in case if you notice that any of your test is slow or if it is actually consuming a lot of energy, a lot of memory, you can actually also profile your unit test. So what you do is you could just right click and do profile. We are also working on bringing that option here so you can easily do that, but they both do the same thing. You just click profile and, okay,
You can remove that test case.
yeah,
Or reword your changes.
just click Control Z.
You need to go there. Yeah.
Okay. I'm going to go ahead and do profile again. And it will give you options to select multiple tools. I'm going to go ahead and select .NET Allocation Tracking Tool. And just going to start my new profiling session. Come on. Yep. So as we saw in the next session, what it will do is it will bring up some auto insights. In this particular scenario, it will bring up auto insights related to the zero length array. Come on. Okay, I'm just going to hold it like this now. Related to the zero length array. And again, you have multiple ways to investigate that. You can investigate that manually or use Ask Copilot, which you saw in next session. It will go and give you the exact code where you need to go and fix those zero length arrays, or just use the simple thing that is, oops, the array empty string, which is a very simple thing which we miss, but that can actually cause a lot of memory issues. So these were two small things which can actually help you improve your unit test experience. Now, actually, that's all we had today. We are a little ahead of time, so we can take actually a lot of questions. Just want to give a quick recap. I think we can do it on yours.
Yeah. Just give me a moment.
Sure. So we saw a lot of features today. So Charlie showed us or started us with some of the context and references things, which will help you just understand your code. Then we saw a lot of debugging features, which are existing but have Copilot assistance like breakpoint suggestions, visualizer, link queries, exception assistance, variable analysis, and then palette stack. And at the end, which was not a very great demo, but we also saw how you can actually improve your unit testing with your profiling or also with the debugging. That's all we have. Thank you so much for being here with us. We actually have a Twitter account dedicated for debugging and profiling team. So if you follow that, you will get our new feature updates or tips and tricks. We try to post that very often. And we have all our updates on our blog and documentation as well. We have a lot of time, so we can take questions. Yes. Thank you.
When he showed that it shows you what's going to be returned when the method is leaving, I've just noticed that, and I've been using. Sorry,
You can use this.
I'll just repeat it since I have the mic and I guess they're recording. When you showed the variable return when it was coming out of the method and it showed it in gray text there, does that require code lens to be on? Because it kind of looked like code lens font, and I'm OCD about my line height and I can't deal with code lens. So
It should be there. It should be there for C++ and .NET code.
okay, I guess I just haven't noticed it. I've been using more than or higher than 17.12 for a while, but I just never noticed it. That's very cool.
Excellent. We try to make it really, we try to not clutter your view. I guess we can do, make it a little bit more prominent. Yeah. Thanks for the feedback.
Hi, great talk. In the example where you were giving Copilot the output window context, What happens if you don't do that? I feel like I've seen it in VS Code where when you're trying to debug something like in VS Code, it will automatically sometimes pull from the output window. So are there plans to have a similar kind of experience on the VS side?
We should add that. That's one of the next things. Like, as you notice, I had to, what's that?
Yeah, it already exists as a tool. Yeah.
It does, but not in the debugging scenario.
Oh, okay.
Right.
Oh, okay.
Yeah. So that's one of the things we're going to look at. As you might have noticed, we added a lot of context elements manually. Obviously, we're trying to make it more seamless so that Copilot can, if it deems it to be important, it should just call the tool and grab the output log and use it in its analysis. That's hopefully coming up soon.
Any questions? Okay, thank you so much for joining then.
You want to show the survey stuff?
Oh, yes. Don't forget to take the session survey.